So hey guys, so this is day 7 of solving programming problems. So we are going to take a look at one of the most interesting problems in Geeks for Geeks, which is to find the minimum number of platforms that's required in a train station. So I'm going to show you what this problem is all about. I'm going to give you an example on how to solve this problem, and we're going to go through two approaches that we can use to solve this problem. One of the greedy approaches, one of the most efficient approaches. And by the end of this video, we're going to implement this in Java, and then I'm going to code it out along with you. So take a look. So the whole idea of this problem is that we are given two arrays. One is called the arrival array and the other is called the departure array. And the arrival array will contain the time that each train arrives in the train station, and the departure array will contain the time each train will depart the train station. And so the idea of the problem is to find the minimum number of platforms that's required in a train station so that no train has to wait for a path to get cleared. So uh, there are two approaches. As I said, there are two approaches. So one of the greedy approaches is that we currently have details regarding the arrival and the departure time of each trains in the array, right? So the idea of the greedy solving is that we would take train one, and we would have the arrival time of train one and the departure time of train one, and we would compare it with every other train in the array. So we would take T1 and we would compare it with T2. And if there's any other train in the array that arrives in between the arrival and the departure time of train T1, we would increment the minimum number of platforms that's required. And once we do all the iteration for T1, we would take T2 and we would compare it with T1, T3, T4, T5, take T3 and we would compare it with every other trains, and we would check if there's any other train that arrives before the arrival and the departure time of the picked train, right? So this is the greedy method to solve this problem. I'm going to show you another efficient way to solve this problem. And in the efficient way to solve this problem, we are going to make use of two variables. One is called the maximum and the maximum needed. So the maximum will store the maximum number of platforms that's required at a specific point during the iteration, and the maximum needed will hold the overall platforms that's required in order for no train to wait, right? So that's the idea. So apart from those two variables, we're going to hold two indexes, index I and index j. This is so that we could do the comparison as we iterate throughout the entire array, right? So the point of this whole problem relies on two conditions that we check between I and j. So we're going to check if the value of I is greater or less than the value of j. So in this case, the value of I is greater than the value of j. What does it mean? So it means that train 2's arrival time is way higher than train 1's departure time. So meaning that train 1 has left the train station way before train 2 arrives at the train station, right? So in this case, what we would do is we would decrement the value of max to 0 since there's no train between train 1 and train 2. And then what we would do is that we would increment the value of j to the next position. So this is the idea here. So whenever the value of I is lesser than the value of j, we would decrement the value of max and we would increment j. So that's the whole idea here. Now we would do the same comparison between I and j, and here the value of I is lesser than the value of j, meaning that we would need an additional train track to hold train 2. So what we are going to do here is that we are going to increment the value of max to 1, and then we are going to increment the value index I to the next position. So in this case, the value of I is lesser than the value of j, meaning that we would need an additional train track to hold train 3 because train 3 arrives way before train 2. So we would increment the value of max to 2. Yeah. So one other thing that I wanted to mention was that during each iteration and during each update of max, we would check with max needed. And if at all max needed is less than the value of max, so in this case max needed is 1, but max is 2, we would increment the value of max needed to 2, right? So we've done this comparison, we've incremented the value of I. Now we've checked the value of I and j, and what we need to do is that we need to increment the value of I to the next position. So in this case, value of I is again lesser than the value of j. So we will need to increment the value of I. We will need to again increment the value of max to 3. And then we will need to check max if max needed. So max needed is less than max. So we need to increment the value of max needed. We will need to update the value of max needed to max. So it will turn to 3. Yeah. we are going to again compare I and j. So here I is actually greater than the value of j. So in this case, we need to decrement the value of max to 2. We will need to increment the value of j, and we're going to check max and max needed. So max needed is already higher than max, so we are not going to change max needed at all. So next we're going to check I and j. Again here j is lesser than I, so in this case we are going to decrement the value of max to 1, and then we are going to increment the position of index j to the next position, and we're going to check if max and max needed. So max needed is again higher than max, so we don't need to update max needed at all. We're going to do the next comparison. So we're comparing I with j. In here j is again lesser than I, so we are going to decrement the value of max to 0. We are checking max and max needed. We don't need to update max needed because max needed is higher than max, and in this case we are going to increment the value of j here as well. So now I is actually lesser than the value of j. So in this case, since I is lesser, we are going to have to increment the value of max to 1, and we are going to increment the value of index I to here. So now we've incremented max. We need to check max if max needed, and max needed is indeed higher than max, so we're not going to update max needed. We're going to check the next condition. So we're going to check max index I and index j. So index I is lesser than the value of index j. So train arrives even before the previous train departs. So we are going to increment the value of I, and then we are going to increment the value of max to 2. So we're going to compare max and max needed. So max needed is already higher than max, so we don't need to do any changes to max needed. Now, if we take a look at I, when we go to the next iteration, we see that I is actually higher than the end of the array. So we've actually iterated through the entire arrayable array. So what we need to do is that we need to break the iteration, and we just need to return the maximum needed that we've found so far, which is 3. So in this case, we need 3 platforms in the train station so that no train has to wait to arrive at the train stations, right? So that's the efficient way to solve this problem. We've just iterated both the arrays just once, and we found out the minimum number of platforms that's required. So now I'm going to go over and solve this problem. So the first thing would be to sort both these arrays. So I'm going to do arrays.sort here. Thank God we have all these handy methods in Java to solve these problems, right? So I'm gonna sort both these arrays, and I'm going to initialize the variables that we need. So far I'm going to initialize maximum to 1, and max needed to 1. And we need 2 more indexes. So index I is equal to 1 and index j is equal to 0. Oops. Yeah. And we are going to have a while loop indicating that I should be less than array.length. Um, Oops. Yep. I should be less than array of length, and then we are going to go in and we are going to check conditions, right? So first, initially, we would check if the array of I is indeed great lesser than the array of j. So this is the first condition, and the other condition would be that the value of I being lesser than the value of j, right? So that those are the both the conditions. So in case of I being lesser than the value of j, meaning that the other train has arrived way before than the previous train has departed, so we would need an additional track, right? So we are going to increment the value of max, and we're going to increment the value of I, and yeah, so those two are the two changes that we're going to make. And if at all the value of I is lesser than the value of j, we're going to decrement the value of max, and we are going to increment the value of j. And once we do those two conditions, we're going to make a check if max needed is lesser than max. So in this case, we would update max needed with max. So once we've gone through all the iteration, we are going to return max needed, right? So this is the idea. I think I might need to add another condition here. Still thinking. Let's just compile this and see if it runs, or else, because we need to check for index I as well, right? So Okay, there is an issue here. Let me see what this is. Sorry guys, it took me some time to figure out where I was making a mistake. And it was such a silly mistake that I was using the same array name to compare both I. So I didn't realize there was a I didn't realize I had array here as well. So that was causing the whole problem. And I was like looking through all the other code. I was changing all this stuff, but like the algorithm is exactly the same. I just made a silly mistake of using the same array name here, and it took me a while to figure that out. So I do the weird cut there. But like the solution is the same. We're sorting the array. We are setting both the max and max needed variables I and j, and then we're doing an iteration till the end of the array, which is n, which contains a number of elements in the array, and we're doing a comparison to check, and we're making changes accordingly. And then at the end, we're checking if max needed is lower than max, and if it is, we are updating max needed, and we're returning max needed by the end of the iteration. So I'm gonna submit this and check if it passes all the test cases, and that should be good. Sorry, there was a weird cut there, but yeah, let's see if it passes. Taking too long to submit it. Yeah, now it's submitting. Yep. So that's pretty much it, guys. So this is the problem. So thanks for listening to this video. Thanks for your patience throughout the whole point of me trying to figure out what the hell went wrong. But yeah, see you guys tomorrow with a new problem.